With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, so we are given with a question which says there are three metal rods made of copper, aluminium and brass, each 20 centimeter long, 4 centimeter in diameter, are placed end to end with aluminium between the two others. The free end of the copper and brass are maintained at 100 and 0 degrees Celsius respectively, assuming that thermal conductivity of copper is twice that of aluminium and 4 times as that of brass. The approximately equilibrium temperature of the copper aluminium and aluminium brass junctions are respectively. So here in the figure we can see uh, there are three rods joined end to end, and copper end of the copper rod is at 100 degrees Celsius and as that of brass is at 0 degrees Celsius. So we have been asked to calculate the equilibrium temperature between copper aluminium and aluminium brass. So let's suppose that the temperature between copper aluminium is T1 and between aluminium and brass is T2. So as we can see, the heat flow, or we can say the heat current through each of the rod will be the same. So we can write Q by T, that is the rate of heat flow, which is given by formula. We can write it as K A delta T by L will be a constant. Alright, will be a constant over here. So we can we have already studied that this is nothing but this is the series combination of three different elements, or the rod we can say over here. So the heat flow between each section or through each cross section will be constant with respect to time. So we can write from this formula we can say the relation will be as we can see the cross section of each of the rod is same, so we can straight away neglect the term A over here, and we can write, let's suppose that this is our, for copper it is 2K, or let's first write a formula. Let's say this is KCU, and delta T would be 100 minus of T1 and dividing it by L1. For copper we are writing, so let's write it as Cu over here, and for here we can say it is KAL, and here it is T1 minus of T2 and dividing it by LAL, and that would be equals to K brass, and here it would be T2 minus of 0 dividing it by LB, that is length of brass. So here we have to multiply the equation with area as well, so we just have, alright, so this is the equation now. So we can say we will try to form the equation in terms of T1 and T2, and then we will try to get the value of T1 and T2. So let's first take these two equations. So we can say that is Ku, that is for copper, it's been given as K 2K, so 2K, and this can be written as 100 minus T1, and AA will get cancelled from both sides, and length of copper that is been given as L, and that is equals to K for aluminium is been given to be as K only, and here it is T1 minus of T2 dividing by L. So from here if we carefully analyze KK, L will get cancelled out, therefore we can say 200 minus 2 T1 will be equals to T1 minus T2. So therefore we can say 3 T1 minus T2 will be equals to 200. So let's suppose this is our equation number 1. Alright, now we have to form one more equation to solve this problem. So we can take these two equations. So we can write K for aluminium, we can write it as, that is, so we can take this two equation now. K for aluminium has been given as K, and AA again will get cancelled from both sides, so we will cancel it straight away, and we will just take the uncommon terms. Length of aluminium has been given as L, KB is given as K by 2, and here it is T2 only, and dividing by L. Length is again the same, so we can see both the common terms will get cancelled out, so we are left with T1 minus T2 will be equals to T2 by 2. Alright, so from here we can say this can be written as T1 will be equals to 3 T2 by 2. Alright, so this is what the relation between T1 and T2 we have derived. So from equation 2 and equation 1, we can say from 1 and 2, if we substitute this value in equation 1, so we can write 3 into T1 can be written as 3 T2 by 2 minus T2 equals to 200. Therefore from here we can say 9 7 T2 by 2 will be equals to 200. Therefore the value of T2 will be equals to 400 by 7, which is approximately near to 57 degree Celsius. Alright, so we have calculated the value of T2. Therefore T1 will be equals to 3 into 57 by 2, and that gives us the value near to 86 degrees Celsius. Alright, so we have calculated the value which we are interested in finding, that is T1 and T2. So if we compare the option, we can say option D is the correct match for this. For T1 it is 86, for T2 it is 57. Alright, so since we can see we have to calculate the equilibrium temperature between copper aluminium and aluminium brass. So copper aluminium it is T1, and for aluminium brass it is T2. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.